Everyone, welcome to another lesson on using derivative rules. Today we're going to find d dx of f of x times g of x if f of x is equal to x squared plus 2 and g of x is equal to 3x cubed minus 5x. Now let us think about what rules we can use to solve a problem like this. Because we're looking at a product, one of the rules that we can use is the product rule. The product rule says that the d dx of f of x times g of x is equal to d dx of f of x times g of x plus d dx of g of x times f of x. d dx means derivative of. So we have f of x, we need to find the derivative of f of x. We have g of x, we need to find the derivative of g of x, and then just plug these into the formula, and then expand, bring like terms together, simplify until we get our final answer. F of x is equal to x squared plus 2, so the derivative of f of x will be equal to 2x using our power rule that we learned earlier. The power goes over and the exponent goes down by 1. G of x is equal to 3x cubed minus 5x. The derivative of g of x will be equal to 9x squared minus 5, again using our power rules that we learned earlier. The derivative of this product then would be derivative of f of x, which is 2x, times g of x, everything in g of x, plus derivative of g of x, which is 9x squared minus 5, times our f of x function. Then we will expand 2x times 3x cubed, that's 6x to the 4th power, 2x times 5x, that's 10x squared, so we have 6x to the 4th minus 10x squared, plus 9x squared times x squared, that's 9x to the 4th power, 9x squared times 2, that would be 18x squared, minus 5x times 5 times x squared, that's 5x squared, minus 5 times 2, that's minus 10. Then we bring like terms together, the 6x to the 4th and 9x to the 4th. 6 plus 9, that's 15x to the 4th. The minus 10x squared combines with the plus 18x squared and the minus 5x squared to give plus 3x squared, and the minus 10 just remains minus 10, and so that is our final answer. That was solved by using our product rule. Let us look at another problem that we can use another rule to solve called the quotient rule. Use the quotient rule to find h prime of x if h of x is equal to 4 root x over x squared minus 2. Now in using the quotient rule to solve this, we have to remember how to formulate our quotient rule. Remember, if we have a function h of x is equal to 4 radical x over x squared minus 2, to find h of x, what we want to do, because we have a radical x here, we have an x squared here, when we have radicals, we want to write the radicals as fractional exponents. We want to write the radicals as fractional exponents. So radical x as a fractional exponent will be x to the 1/2. Okay, so remember those rules for converting radicals to exponents. And then we can apply the power rule to this, x to the 1/2. So we're going to treat f of x as a function for radical x, so that is going to be equal to 4x raised to the 1/2. H of x is f of x over g of x, so g of x will be the denominator, that's x squared minus 2. Then we need to find f of x and g of x, and then plug this into what we have as our quotient rule. So f of x, f prime x, will be equal to our constant times the power, so we pull our constant out, so that's 4, times our power. We bring the 1/2 over. So that's times 1/2. And then in the exponent, what's going to be left is 1/2 minus 1. So that gives us negative 1/2. 4 times 1/2, that is 2x raised to the negative 1/2. That is our derivative of f prime of x. Then for g of x, g prime of x, look back at g of x. G of x was x squared minus 2. X squared, that was a power. Use our power rule. Bring the 2 over and subtract 2 in the exponent. Subtract 1 from 2 in the exponent. So g prime of x would be equal to 2 times x raised to the 2 minus 1, which is just x to the 1. When we have x to the 1, we do not necessarily write the 1 because x to the 1 is just x. So g prime of x will be 2x. And remember also, for a constant, when we differentiate our constant, we get 0. Right? The derivative of constant is also 0. 0. So we only left with g prime of x equals 2x. Now, let us recall what our quotient rules say. Remember our acronym that says low d high minus high d low over low squared. We're going to try to use that. So h prime of x will be equal to g of x times f prime of x, which was the denominator, times the derivative of the numerator, f, minus our numerator times the derivative of the denominator. So that's low d high minus high d low all over low squared. Someone might say low low, however you remember it. Now let's plug in our values for g of x, which is x squared minus 2, f prime of x, which is 2x to the negative 1/2, minus, we got our 4 radical x here. We're going to rewrite it as 4x to the 1/2, and then 2x is our g prime x. So let's do that. Let's do that and let's see what happens. So this now will be x squared minus 2 times 2x to the negative 1/2 minus 4x to the 1/2 times 2x all over x squared minus 2 all squared. Okay, we will not expand the denominator just yet. We're trying to expand the numerator first and see if anything can probably cancel out or come together nicely. If we FOIL out x squared minus 2, so x squared times 2x to the negative 1/2, that leaves us with 2x to the 3/2 because we're adding exponents, and 2 minus 1/2, that's 1.5, which is the same as 3 over 2. And then 2 times 2, that is 4, so that's 4x to the negative 1/2, minus 4x to the 1/2 times 2x, so that's x to the 1, and x times x to the 1/2, that would be x to the 1 plus 1/2, so that's x to the 3/2, and then 4 times 2 is 8, so that's how we got our 8x to the 3/2. Keep the denominator the same, so j prime of x is equal to negative 6 to the 3/2. Why? Because we have 2x to the 3/2 minus 8x to the 3/2. They're the same exponent, so we subtract the coefficients. And then minus 4x to the negative 1/2 over x. squared minus 2 all squared. And I'll accept the answer up to here. However, we can try to continue factoring and see what happens. So what we can do is that we can factor out the negative 2 to the negative 1/2 out of the numerator. And so that becomes negative 2x, to the negative 1/2 times 3x squared plus 2 all over x squared minus 2 all squared. And then finally we can rewrite our fractional exponent as a radical. And so our final answer will look like negative 2 over radical x. And then all times 3x squared plus 2 over x squared minus 1 all squared. It is also okay to just factor out a 2x to the negative 1/2 out of the top. And so if you only factor out a 2 from there, you would end up with something like or 2 negative 3x squared minus 2 over radical x squared minus 2 all squared, something like that. Those are equivalent. Ready? Let's look at one more question from this lesson and see what we can get. Let's do an application question. The position of an object on a coordinate axis at the time t is given by s of t is equal to t over t squared plus 1. What is the initial velocity of the object? So a position function, we know s of t is equal to t over t squared plus 1. The velocity function, we know, is the derivative of the position function. A position function which is s of t is equal to t over t squared plus 1. So our velocity is s prime of t, and that is going to be d dx of t times t squared plus 1. That is low d high minus d dx of t squared plus 1 times t, so that's also high d low, over t squared plus 1 all squared, which is our low squared. Then we plug in what we got for each of these items, or what we have for each of this item. The derivative of, this should be d dt. d dt. I wrote the x here, but these are d dt's because our input is t. d dt of t is 1 times t squared plus 1 minus d dt of t squared plus 1, that's equal to 2t times our function t all over t squared plus 1 squared. Let's expand. This becomes t squared plus 1 minus 2t squared. After expanding the numerator, denominator, we just keep it as is, t squared plus 1 all squared. And then try to simplify that as much as possible. So that becomes 1 minus t squared in the numerator over t squared plus 1 all squared. So that is our v of t function. That's our velocity function. Now our initial velocity occurs where t is equal to 0. So we plug in 0 for t in our velocity function. So we have v prime of 0 is equal to 1 minus 0 squared all over 0 squared plus 1 all squared. So our final answer there is 1. So our initial velocity is equal to 1. Thanks for watching. Please like and subscribe. See you next lesson.